So now we will talk about standard deviation, which is denoted by a Greek letter which is sigma. I am writing in a bracket also. It is defined as positive square root of the arithmetic mean of the square of deviations of the given values from their arithmetic mean. So basically in mathematical way it is represented as square root 1 upon n summation over I is going from 1 to n fi xi minus x bar whole square. This quantity is squares of deviation of the given values from arithmetic mean, where our arithmetic mean is x bar. So you can write where x bar is arithmetic mean of the given distribution, and summation over fi, where I is going from 1 to n, is equal to our capital N, that is total frequency. So this expression is actually for the frequency distribution xi oblique fi, where I is going from 1 to n. So the step of squaring of the deviation, that is xi minus x bar, overcomes the drawback of ignoring the signs in mean deviation. So we can say standard deviation is also suitable for further mathematical treatment. I am going to write also. So I am just writing in a second note, that is the standard deviation actually satisfies almost all the properties laid down for an ideal measure of dispersion. So we can say standard deviation is the best and the most powerful measure of dispersion. So here I have written that standard deviation satisfies almost all the properties laid down for an ideal measure of dispersion. So you can say that standard deviation is the best and the most powerful measure of dispersion. So now we will talk about square of standard deviation, which is actually called variance. So basically when you square the standard deviation, then you will get variance, and which is given by, as we know, sigma is the standard deviation, then you have to square it, so it will become sigma square. And there was a square root expression in standard deviation, so when you square that expression, it will become only 1 by n summation over I is going from 1 to n fi xi minus x bar whole square. That square root expression will be gone. So this is the expression for variance. Now you have to know about what is the variance actually. So basically variance measures how far a set of data is spread out from the mean of the given data set. Suppose this is your frequency distribution and this is the mean, that is I am just taking it x bar, which is mean. So suppose all that data are spread out in this distribution like this. So actually what does variance? Variance actually measures how this set of data is spread out from this mean of the given data set. Now we will talk about variance of the combined series. That is, if you have two series and you have to find the variance of the combined series, then how will you get that? So the topic is here variance of the combined series. So you have to first take if n1 and n2 are sizes x1 bar and x2 bar are the means, and sigma 1 and sigma 2 are the standard deviations of two series, then variance sigma square of the combined series of size n1 plus n2 is given as, it is actually sigma square is equal to 1 upon n1 plus n2 whole multiplied by n1 into sigma 1 square plus d1 square plus n2 times sigma 2 square plus d2 square. You have to take it in a bracket. This is the formula to find out the variance of combined series, where d1 is equal to x1 bar minus x bar, and d2 is equal to x2 bar minus x bar, where x1 bar and x2 bar are the means of the given series respectively, and x bar is mean of the combined series, which is equal to n1 x1 bar plus n2 x2 bar whole divided by n1 plus n2. As we know, we have discussed this before in mean section. You can write also mean of the combined series. So basically you have to use this formula to find variance of the combined series.